Okay, it's Friday again, so we'll get started soon. Just 1 minute. Uh, Let me double check a few things. Uh, okay. Okay. Good afternoon, everyone. Welcome to TGI Pulsar, episode 15. And it's me again, and I'm happy to kind of share today's topic is more talking about what's new in Pulsar 260. And Pulsar 260 was released a couple of weeks ago. It's a huge milestone to the Pulsar community, and there's a lot of great features, and also because it's a um, major milestone. So some of the features might not been covered by some of the documentation very well, but we have our technical writing team has been working aggressively on kind of catching up all the documentation, making sure we deliver great documentation about the whole Pulsar project. And so in today's episode is I would like to kind of work through what's new in Pulsar 2.6.0 and some of the features that you can leverage in production to meet your requirements. And as usual, we'll get started with a week in review, and I will share my kind of hack MD notes into the YouTube chat in case everyone want to will check the notes. And let me zoom in a bit. Whoops. Okay. It also has been kind of very exciting week. I would say 2 weeks because it was a holiday last week in the United States, so we didn't do any episode last week. So it has been a great 2 weeks in the Pulsar community. So the first thing is we officially published the a Pulsar Helm chart to Helm Hub. That has been asked by a lot of people in the community, and we finally do that. And so the official Helm chart is kind of available in the Apache organization. It's called Pulsar Helm chart, and it's maintained by the Pulsar PMC. And a lot of contributions has been made to this Helm chart. The PMC will continue on maintain this Helm chart and simplify a lot of deployments for Pulsar running on Kubernetes, and as well as bring the feature parity between Pulsar and as well as the Pulsar Helm chart. So people is able to use Helm chart to enjoy all the features bring were brought into Pulsar project. And you can go to the Helm Hub, find the search the Helm chart. You're able to find that in the Helm Hub, as well as we also publish that to Artifact Hub. I think Artifact Hub is CNCF hub for hosting all the Kubernetes artifacts. So you can use Artifact Hub to find Pulsar Helm chart as well. And we also update the documentation. Then you don't need to clone the Helm chart repo anymore. You can just run Helm repo add Pulsar and then the chart address. So basically, all the charts is published into this location, and it will contain all the versions that would be published along with the Pulsar releases. So very excited kind of achievement in the community, and hope everyone who has been running Pulsar in Kubernetes can contribute to this Helm chart. So every contributors in the Pulsar community can maintain a good quality of Helm chart. So this is the official Pulsar Helm chart. In terms of feature wise, there's a kind of big, I would say there's multiple efforts has been made in both the main repo as well as the different client repo for adding OAuth 2 support. So OAuth 2 has been kind of a great standard for authentication, and it has a lot of plugins and a lot of identity systems, authentication, authorization system support OAuth 2. And with this change, we basically bring in the OAuth 2 support to Pulsar, so you can use OAuth 2 authentication for every different language of a client, like from Java, C++, and Go, and all the way to Python, and sometime in the future would be Node.js. So this will bring in kind of enhance the security feature that provided by Pulsar. So it's a great change, and it's going to be released as part of the 2.7.0 release. So just like follow Pulsar and watch the kind of a release schedule, and you will see OAuth 2 support coming out soon. And on the Pulsar Go client side, there's I would say a huge momentum on developing the Golang client, and a lot of people using Go on developing their messaging applications. So a lot of features has been a lot of enhancement, and as well as the features has been developed in Pulsar Golang native Go client. And one of the interesting features has been added is the interceptor support. For people who might already using interceptor in Java client, and this feature now is available in Go client. So you can using this interceptor, and by integrating the interceptor with maybe open tracing, open sensors, and to trace any messages that you produce by the Golang client. So it's a very great features being added to the native Go client. And on the functionalities on the Pulsar function side, there's a new algorithm has been introduced in Pulsar function scheduler that is for the function scheduler to balance the functions on different workers. Because if we don't moving the functions or like rebalance the functions, we slowly restart the workloads for functions might become skewed. Then this mechanism is basically ensure that the function worker can run if the functions can be evenly distributed across the function workers. So this is it's probably not a problem if you run functions on Kubernetes, because the functions will be run as individual parts in Kubernetes, and Kubernetes would actually scheduling the pods in different worker nodes. But if you are running Pulsar functions using process mode or thread mode, then this feature is definitely something you should check out, and it would help you in the situation that if you have a very large function worker cluster and you are making sure your function is evenly distributed across the function workers. So this is kind of the uh, a snapshot of the excited achievements in the Pulsar community in the last 2 weeks. And for more, if you're interested in the like what's happening in Pulsar, especially if you want to take a snapshot about what are the future features, what are the bug fixes has been developed and introduced in Pulsar. If you want to keep an eye more closely on those development activities, you can also check out our weekly report. Our team has been working on creating a snapshot of what's happening, especially on the development side, what's happening in the Pulsar community. And we maintain that as a kind of weekly update. And you can easily go to StreamNative website and find the Pulsar weekly. And if you click Pulsar weekly, it will show like what has been done or what has been happening in the past week. And that is a good location for you to check out all the activities happening in the Pulsar community. And besides that, I would like also to share an article that we have been working on responding to a conference blog post about Kafka versus Pulsar versus RabbitMQ, which doesn't provide an accurate perspective on some of the technical uh, discussions. So this blog post is basically trying to provide a more accurate perspective on both performance, architecture, as well as features. And we published this on Wednesday, and it cover a bit. We also format this in a sequence more closely to the conference blog post. So if you want to do a side-by-side comparison between what we are talking about and what a conference talking about, that you can also compare side by side. But basically trying to give people more on the idea on different kind of feature comparison and the operational simplicity and performance in different kind of architecture. I would say different of the technical comparison. So I hope that give you a more solid and accurate view on the pulsar technology. And in next week we also we are going to publish the second part of this blog post, which will be more focusing on the use case adoption and as well as community, and to address some of the misunderstanding about Pulsar community in conference blog post. And so if you would like to check out the that blog post, you can watch out. You can follow us on Twitter. We will publish that blog post and tweet it when it happens. And this is more about the kind of what's happening in the Pulsar community last 2 weeks or last week. And so go back to today's topic is I'm going to walk you through about what's new in 2.6.0 and highlight some of the features that I really like. So you can also click the link I share in the YouTube chat. I can repost it again. Okay, let me zoom in. Oops. Oops. Great. Okay, so we kind of for each Pulsar release, besides the the official release note, we encourage the release manager usually write a blog post about kind of a snapshot about the most interesting and major features that has been added on each partial major release, even some of the minor release as well. And that is try to provide, I would say, a better view to what exactly happening in one parcel release. So people don't need to go through like a huge paper of the release notes and to identify what exactly you would expect from a parcel major release. In 2.6.0 particularly, we have been working on a lot of great features, and we include about like 450 commits from different committers from different companies, and those features kind of spread across from the core to the storage and to functions, as well as Presto Circle, and also including all the enhancements that would happening in different client libraries. And so I would kind of use this chance to walk through some of the.
So the first one, what we oh, whoops.
Okay, sorry, I think my headphone has some problems as the my laptop it was lost. So I hope it's coming back now. Let me double check. Okay. So let's go back here is on the call parser side. One of the exciting features that has been added is called large message size support. For people who use Pulsar before, Pulsar have message size limitation, and that size by default is capped by 5 megabytes. So you are not allowed to publish master that is larger than 5 megabytes, but you are able to tune that settings by kind of enlarge the size limitation. You can like set the size limitation to kind of 10 megabytes, or set the size to kind of 20 megabytes, but it's still not an efficient way to support large master size. So in this PIP 37, we introduced a mechanism is basically trunking the large messages into smaller message chunks, and that will be produced to a parser topic, and parser will guarantee all the messages will be produced together, and when the consumer receive the messages, it will form the large message back to the consumer. So from end user perspective, there will be no difference. You will not you will not notice any difference as how you consume from a normal master, because the underlying the broker and as well as the client would handle that seamlessly for the application. And what you need to do is on the producer side, you need to set a setting called enable trunking. And once you have that setting enabled, then you are able to view to support like produce large messages. And for people who are interested in the details, you can just go check the pull request 4440. And the second thing is we introduce uh, mechanism called system topic. The idea, it's not a complete story yet, but it's bring in the mechanism for Pulsar to implement a system topic to achieve to be able to capture every changes that is happening within a cluster, within a tenant, even within a namespace. And the idea was originally, sorry, the mechanism was originally designed to support the topic level policy. Because for people who know about the Pulsar namespace policy, we only have the policy in the namespace level, and the policies actually apply to all the topics within the same namespace. But you are not allowed, or it's you are not Pulsar is not capable for you to override a policy for a given topic within the namespace. Hence, so we want to support the topic namespace, so topic policy, but we don't want to store the policies, individual topic policies in ZooKeeper, because that would result in a lot of result in Pulsar need to address store a lot of the metadata in ZooKeeper. So we kind of step back, and is there any mechanism for us to start the topic level policy? So we take an event sourcing pattern and using kind of a system topic to propagate the topic policy. So every broker is able to use the system topic to get the updates on the topic level policy. And we don't need to store the topic policy in ZooKeeper, but instead it would be stored as in a system topic, and that would be converted to be stored in the BookKeeper, and it's actually scalable. So PIP39 is basically set the foundation, but we still haven't complete all the topic level policy support. And if anyone is interested in adding the topic level policy support, you can check out PIP39. The foundation is there, and it just needs some work to provide a topic level policy. Okay, next one is also in the core. So it's a very exciting feature. It's about the pluggable metadata interface. So Pulsar is using ZooKeeper for the configuration store, as well as for storing some of the metadata for the topics, as well as the ledgers for BookKeeper. In BookKeeper, there's already a metadata abstraction, so it allows you to plug in different type of the metadata storage as the backend, and BookKeeper support both ZooKeeper as well as etcd, and Pulsar doesn't have that interface. And in 2.6.0, we introduced this pluggable metadata interface. This allows people to you choose a different metadata storage for Pulsar. So you can, if you already use ZooKeeper, you can still using ZooKeeper. But if you are already using etcd, then you can choose plug into etcd, or even in cloud, if there's any other hosted version for the metadata storage, then you can write your own plugin. But the most important thing for this pluggable metadata interface is it allows us to write customized metadata storage for Pulsar, and to extend the scope of this pluggable metadata interface is we can implement the metadata service as part of BookKeeper. So, then when you run BookKeeper cluster, it can bootstrap and bootstrap a metadata service, and the metadata service can become a scale out metadata storage as how we scale out the data storage for on bookies, and this would provide the mechanism to get rid of ZooKeeper eventually. So you can think about these features is the first step for us working towards removing ZooKeeper dependency. Excited. Uh, so the next one is the P50 For, and that is also very interesting, and also it benefits a lot of use cases, or maybe it address some of the I would say strange behavior you might have been observed before about acknowledge and negative acknowledge that you will see from the from Pulsar side. So to understand this feature is we need to go back a bit on understanding how like Pulsar store messages. So you know in Pulsar, all the messages are batched into entries, and individual entries has been will be stored in bookies. On the broker side, the acknowledgement is only tracked in the entry level. So it doesn't track the individual acts for the messages that batch into one entry. So it has to wait until all the messages of a given entry has been acknowledged, and then it can assume the whole entry has been acknowledged. This would result in, I would say, uh, duplications when act timeout, broker failures, because uh, if let's say if entry has 10 messages and you already acknowledge 9 messages, but there's only one message is not acknowledged. On the broker side, it's not broker is not able to mark this entry as acknowledged because there's still one message within that entry is not acknowledged. So uh, uh, the end the acknowledge the acknowledgement mark will not be returned to the cursor. If the broker crash, like the negative negative acknowledge is sent back to the uh, broker to ask for redeliver, the broker would potentially redeliver the whole entry back uh, to the to the client side, and this would result in those 9 acknowledged messages are redelivered to the consumers. So this is the duplication that would happening in the acknowledgement side. And you probably would observe this behavior if you're using like enable batching and do these act timeout and negative act. You would always observe the duplications uh, in some occasional case. So this fix is basically change the acknowledgement tracking model in the broker side. So after this change is Pulsar is able to track the acknowledgement in the at the in the mastery level, or what we call at the individual batch index level. So this when a whole entry has to be redelivered, it will it would redeliver a bit set that would tell the consumer what messages has been acknowledged within this batch. And the consumer is able to fill out those messages that has been already acknowledged. And that is a very useful features. It would reduce a lot of duplications that can potentially happen when failure occurs. And but it's a change that in that involves some of the protocol changes. So if you want to use this feature, you need first enable this feature in the broker side, and you also need to upgrade your consumer to 260. So this is a feature a feature that you should check out if you kind of see if you experience this strange behavior before and turn off batching. Now you can turn the batching mechanism on again, but still do the this batch index level acknowledgement. So this is a super cool features. And next one is related to data later queue. So for people who use data later topic features in Pulsar, is it's a consumer side feature, and but broker would tell a consumer how many times a feature has been redelivered, and the consumer based on the redelivery count to send messages to a data later topic. However, there's no kind of any retry logic that the before a message would be marked as uh, would be sent to the data later topic. So in P58, basically introduce a mechanism called retry later topic. This would put the messages to kind of a retry queue, and the messages would be retried in the retry queue, and then the consumer would kind of consume later. It can specify a kind of a delay time for how long you want to kind of retry this message again, and this will provide a mechanism before individual attempts. You can insert a certain retry duration, and that is very flexible for you to control how your retry policy you want to deploy for your data letter policy. So that is the 58. It's a consumer side features. Uh, PIP60 and PIP61 is kind of related to, I would say, more or less close to Kubernetes environment. On PIP60, it provides the support for using other proxy software like the ATS, HAPoxy, Ninjax, Envoy that who already support SNI routing. Uh, then you can just use those proxy software. You don't need to use the Pulsar proxy. And this will support, you can route the traffic to a broker port without terminate the SSL connections. And this would hugely increase the security, um, uh, I would say security guarantee in the proxy there. And also, if you already kind of having any of these proxy software like ATS, Ninjax, and Envoy, probably your operation team already very familiar with those software. You can just leverage this software. And this PIP is making the change to a bit on the Pulsar protocol. So it requires the changes in the Pulsar client. So in order to providing this support, you need broker upgrade to 260, and then you can use the proxy software that already support SNI routing, and then you need to make sure your consumer your Pulsar client is upgraded to 260. And the current support, I think it only is only available in the Java client. It doesn't. It's not available in the other language client. But we'll probably add some of the support in the future. And PIP 6.1 is a bit kind of different in the Kubernetes deployment. As you know, in Kubernetes deployment environment, if you want to expose the Pulsar service outside of a Kubernetes network, you have to deploy a proxy. And currently it's a Pulsar proxy. And with PIP60, you can use a different proxy software. PIP61 is taking a bit a different route. Is thinking if is there any mechanism that is available to support like running Pulsar in a Kubernetes environment without a proxy. In order to make this happen, you need to make sure a broker pod is able to advertise multiple address. An internal address that can be used by for the inter broker communication, and for clients outside of Kubernetes cluster, you need to advertise a public address so that your Pulsar client can connect to the broker pod using that public address. And PIP61 is providing that support. You can specify how you want to advertise multiple address into BookKeeper, so the broker is able to discover different addresses for a given broker. And the only only change you need to make in the client side is you need to specify which listener I'm going to use. Whether are you going to use the internal address or are you going to use the external address? So this is PIP61. In order to leverage this feature, you need to upgrade your broker into 260 and as well as using a newer version of the Pulsar client. And PIP61 is adding Pulsar source support to support batch source. I think we talked a bit about this in one of the previous kind of episode, so we can skip this. But it basically extends the capability of connector ecosystem. Okay, so the load balancer one, this is an interesting feature. It's probably an internal features happening within Pulsar, but it's a very useful feature for if you're running a large cluster and as well as sending a huge volume of data. It would make sure the load it can evenly distribute across the brokers and without seeing a broker has more traffic than other brokers. And it does that is by introducing a new load shading strategy. Talking about load shading strategy is I need to expand a bit how the current algorithm work. So currently, Pulsar has this load balancing mechanism that would automatically unload some of the namespace bundle based on the resource usage of a given broker. But the load shading strategy is based on a percentage of the maximum resource usage for a given broker. I think by default, the problem is it usually hard to find a percentage of that resource usage. For example, if I set the resource usage to be 80%, That means Pulsar will not do any load balancer, not offloading any namespace bundles if the resource usage for a given broker is under 80%. But the situation is you might have heavy like heavily used broker, but some other brokers became idle. They might use like 20%, and some of the other brokers might use 80%. And this is not good for usage, sorry, not good for like load balancing as well as optimize the resource usage across the Porsche cluster. And the new load shading strategy is basically changing the behavior. It actually not using a kind of a percentage based on the maximum resources of a given broker. Instead, it's using an average as the threshold to determine if I need to offload some of the namespace bundles to other brokers. So this would ensure like every brokers in the cluster would get equally resource usage, and that would definitely improving your resource usage overall, and also it would make sure your workload can evenly distribute across the brokers. So this is an exciting features in Pulsar. If you have been experiencing any issues related to load distribution, definitely try out this new algorithm. By trying out, you can just simply set the load balancer load shading strategy to the new threshold shader, and then restart your brokers. So it's a very useful features. If you are running at a high load, definitely check this out. Uh, okay, so another kind of major changes that happening in the key share subscription is by adding a support for the consistent hashing algorithm, and as well as fixing some of the ordering issue in the existing auto split mechanism. And in order to support that, you can just add enable this in the broker configuration file, and then you don't need to change any um, your existing consumers, because this is a purely broker side feature. You can just turn on this feature without changing any code. Uh, Besides that, KeyShare also support what we call key hash range reading. What does that mean is right now, most of the key share consumers kind of receive a key range automatically, because that is broker would determine which key range should be like assigned or sent to a given consumer, either through an auto split algorithm or through a consistent hashing algorithm. But sometimes you might want to control how you want to split the key ranges across your consumers. One of the example would be writing a Flink job. So in order to support exactly once in Flink, usually a source implementation would use reader, and the current Flink source implementation is basically assign individual partitions to a given source instance, and it will checkpoint the partitions for each partitions in a checkpoint. And through this mechanism, it ensures that the exactly once processing within a Flink job when it reads the data from Pulsar. But the approach is limited. So the parallelism for the source is limited by the number of partitions. So this is usually the problem you will see from like other messaging system like Kafka. So we want to get rid of the limitation when Pulsar is being used in a stateful processing or in exactly processing scenarios. Then we want to kind of allow the consumer to determine how I want to hash the data, or how I want to assign the key ranges into different readers. And this is the features we support. You can open a reader, specify a key range, and the reader will receive all the data from the key range. In that way, the reader can be, when you integrate with a Flink job, you can use the key range. You can start the offset of a given key range and in the checkpoint. So when a Flink job fail, then when it restart, it will find the key range and like try to resume reading from the position of that key range. Because the key range, the offset of key range is stored in the checkpoint, the checkpoint is stored along with some of the other states of a Flink job. This would ensure if I want to reassign a key range to a different source instance, I need to I need to split the state. And when split the state, I can just kind of split the key range by myself and assign different key ranges to different source instance, and different source instance can read different key range. And this would ensure we are able to support uh, exactly once processing in Flink, uh, while scale up the number of the source instance beyond the number of the partition. So this is a very useful feature for people to develop stateful applications using Pulsar, but not limited by the number of the partitions. So this is the key hash range reading. Besides that, there's a couple of performance enhancements like on the using the pure Java air compressor instead of the JNI based library. This can improve the compression using LZ4, JSDD, and the Snappy. And this is more on the performance enhancement side. Another features you might be interesting to a lot of people who run Pulsar cluster in a large organization. And the idea here is to allow a multiple Pulsar cluster can share one large BookKeeper cluster. The reason to do that is, BookKeeper is a stateful cluster. In order to kind of fully leverage the utilization or maximize the utilization of your storage cluster, one common deployment model people will use is just have a very large bookkeeper pool, and that will be serving your storage pool. And you can run individual broker as a stateless layer on top of the large broker pool. And individual broker, the broker cluster can share one large bookkeeper pool. And this is very useful if you want to isolate the traffic that would sending to your broker, or if you want to kind of dynamically scaling up your broker cluster that independent of your bookkeeper cluster, then you can just set up a broker cluster that talking to a shared bookkeeper pool. This will maximize the storage utilization in the organization. And we have been observed in a large organization. This is a very common approach for people to do that. Is you can have a shared broker cluster, but still have the some dedicated broker cluster for some mission critical like organization or teams for like segregate the traffic, but still you can share a large storage pool. And that is because scaling up, scaling down the broker is much easier than scaling up and scale down storage layer. So this feature is enable the kind of the mechanism to allow such kind of the deployment. And if you have been running Pulsar in a very large scale, I think definitely check out this to optimize uh, your deployment. Another features is about delete inactive topic. I think I covered this in one of the episodes before. But basically the idea is right now is an inactive topic is only deleted when there's no producer, there's no subscription, there's no other producer or consumer connect to the broker. Uh, in 2.6.0, we introduced a feature called like delete inactive topics when all the subscriptions are caught tab. That means it would only delete an inactive topic when there's no producer, and all your subscription already caught up with to the last messages. And this is very useful if you if you are using this feature combined with Reggae's subscription, because in a lot of use cases is you are using some temporal topics for sending the data, and once you finish using this topic, you want the system to recycle the topic. But if you're using a regular subscription, the subscription is always there. You are not it will cause the topic is not able to delete. And with this feature, you can still have the regular subscription, but the topic will be recycled after the regular subscription are all caught up with these topics. So this is a very useful features for the combining to be used for regular subscription. Yeah. Some of the enhancements on the stability. Okay. Okay. So another kind of the performance enhancement is done on the optimizing how consumer fetch the messages in case of the batch messages. So right now when we fetch, so there's a kind of misalignment between the consumer and the broker. So broker always process messages in batches, what we call entries. But the consumer side, we usually always process messages. So in the current flow protocol, is consumer is asking for messages from the broker side, but broker would dispatch the messages based on entries. So there would be a misalignment between the between the number of messages the consumer asks for and the number of the messages that broker dispatched to the consumer. And this mechanism is basically maintain an average size, average number of the messages per entry, and use uh, that average number to calculate, to convert like how many entries I need to dispatch. This would improve the kind of the this will kind of bring the consumer to align with the broker, or align broker with the consumer. So you will see more precise the messages when a broker dispatch the message to the consumer side. And to enable this feature, it's very simple. It's just like set precise dispatcher flow control to true, and it will leverage some of the historic statics of messages and use that to determine how many entries I need to dispatch to the consumer. So check this out if you kind of want to enable some of these features. And okay, some of the features in the key schema, and on the proxy side, and also some of the newer commands has been added in the Pulsar admin RESTful API. Like for example, right now you're able to use get message by ID to read individual messages, and that would be really helpful for you to inspect a single messages within a given topic. Supporting delete the subscription, force delete a subscription. On the function side, there's a couple kind of features has been introduced, like similarly as connectors, now functions support built-in functions. So you can use this built-in function to dispute some of the commonly used functions in your organization or in your deployment. And Go function enhancement on bringing the feature parity as Java functions. Support TLS configurations for both function worker and broker, and some of the enhancement on configuring consumers in the functions and connectors. On the SQL side is two major changes. Is one to support the key value schema. So if you are using schema on your key, then Pulsar Circle is able to figure out what is the key schema and map the key schema into fields in a Presto table. If you have a topic with multiple Avro schema version, previously, Pulsar schema is not able to process the Avro schema correctly. With this change, Pulsar Circle is able to query data from topics that has multiple Avro schema versions. And some other changes on the client side in, for example, support loading TLS from an input stream. Yeah, I think those are kind of the major features that has been introduced in 2.6.0. Most of the major features has been done in the server side, and they're controlled by a feature flag. So you can turn those features on and off depending on your requirement. And some of the features might require you upgrade to 2.6.0. I would encourage you to check out the release notes of 2.6.0 and to understand individual features and turn on those features you need. And if you have any questions related to those features, or you're not sure how to use these features, feel free to reach out to us through Pulsar Slack channel. You can ask questions on Twitter or GitHub. We have different channels for people to ask questions, and we try our best to keep all the documentation up to date for those major features. And if you find some of the documentation is missing, definitely create the issue for us. We will catch up those issues and then address some of the problems that you see in the documentation side. And that's all for the today's episode. I've been covering what's new in 2.6.0, and I would like to thank you everyone for kind of attending this episode and watching this episode. And thanks again. And in starting from probably next week or the week after, we are going to change a bit on the format here to make the TGI Pulsar be more interactive. So we might be using Zoom webinar or Zoom meetings, but we still would be live streaming the whole uh, session to YouTube. So you can either choose Zoom meeting or Zoom webinar to join the TGI Pulsar, or you can still watch this on YouTube. And we would post some of the updates in the coming weeks, and just keep an eye on either on our YouTube channel or on Pulsar mailing address, or follow us on Twitter. And that's all for today. And thanks everyone, and hope everyone has a great weekend and enjoy the time.